Hello, today we will be talking about perpendicular bisectors. And so we will start off with our theorem, and our theorem says that if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. So we have here, if line CD, so our line CD is perpendicular to AB, then AD and DB are congruent. These two are the same. Whatever value AD is, DB will be that same value. And so with that said, this theorem also says that segment AC is also congruent to segment CB. So AC will be congruent to CB. So again, whatever value, whatever distance this is, CB will also be that exact same distance. The converse of that theorem says that if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of that segment. So this here, and it lets us know that line segment AC is congruent to segment CB. And so if we have that, then we know that line CD is perpendicular to line AB. And it also says that AD has to be congruent to segment DB. So these two are also congruent. And of course it says CD is perpendicular to AB. So let's take a look at how we would do these algebraically. So number one says find the value of x. So here we have a triangle. We see that there is a line cutting it, and it is forming a 90-degree angle, and also these sides are congruent. So we do know that these are in fact perpendicular bisectors. So with that theorem, again, these two are congruent, but also these two bigger sides are congruent as well. So that is exactly how I will be setting those two up. I am going to say 7x plus 24 is equal to 13x minus 48. 7x plus 24, 13x minus 48, right. So our first step would be to move our smaller variable. So I'm going to subtract 7x from both sides, cross it here. 24 drops down, and we have 24 is equal to 8x minus 48. I am going to be adding 48 to both sides. So this cancels and this will add up. These two will be 72 equal to 8x, or my bad, that's 6x. So ignore that, that is 6. 6x. And then our last step will be to divide by 6. Again, my bad, this is 6x. Our final answer will be x is equal to 12 once we divide those by 6. Number two looks like the converse of the perpendicular bisector theorem. So we do have this side, and these two are congruent, which means that this is a perpendicular bisector, and therefore these two are congruent as well. So I will set it up like that. I will say 17x minus 3 is equal to 9x plus 13. I have to move my smallest variable first, so I am going to go with 9x here. So this cancels. Then minus 9x over on this side. We will subtract those two, and this one's the one that leads me to 8x. Minus 3 is equal to 13. we are looking to isolate x. So I'm going to move my 3 over. These are going to cancel. This is going to drop. So I'm going to say 8x is equal to 16. Our final step is to divide both sides by 8. These are going to cancel, and eventually x is going to give me 2. Let's move on to 3 and 4. So, for numbers 3 and 4, I do want you to pause this video and give them a shot by yourself, and then come back and see what we get together. So let's pause this video right now and give it a shot. We should have tried to find 3 and 4 by ourselves, so let's check that out. So we have number 3, and it says find RS. So that was different from number 1 and 2. So we are looking for this entire segment right here. We have to check to see if it is a perpendicular bisector, and we can see that it intersects QS, it forms a 90-degree angle, it has 2 congruent sides. So automatically we should know that these 2 are congruent as well. And when things are congruent, we set them up equal to each other. So we will say 7x minus 22 is equal to 4x plus 5. We should have moved our smallest variable and combined our like terms. So we should have gotten 3x is equal to 27. And then our last step was to divide by 3. And we should have gotten x is equal to 9. However, we are not done. Remember, we are looking for RS. And RS, we were told, was 4 times x plus 5. So I'm going to take this x that we found and substitute it back up here. So we will say 4 times 9 plus 5. We will plug that in our calculator or do it in our head, and we should have gotten RS is equal to 41. Number 4 asked us to find EG. And we have to check if it was a perpendicular bisector. We knew it was because these 2 sides are the same, so this is the converse. So that means these 2 sides, EG and GF, are congruent. So again, I will set them up equal to each other because of that. So we say 2x plus 11 is equal to 14x minus 37. We should have combined our like terms by moving our smallest variable. And we should have gotten 12x is equal to 48. We divide those sides by 12, and we should have gotten x is equal to 4. However, we were looking for EG. So EG is equal to 2x plus 11. Again, let's substitute our x. So that should have said 2 times 4 plus 11. So our final answer would have been EG is equal to 19. So EG was 19. That means that without doing any math whatsoever, we could have also automatically known that GF was also equal to 19. Let's go ahead and do number 5 and 6. When you are done, come to me and let me see what you got.